Welcome to Math 1324. We are looking at section 1.2 on lines. Lines are straight, and as you can see from the picture here, the line can go upward. Now I'm looking from left to right. This line is going up, so we say it has a positive slope. We represent slope by the letter M. Think M for mountain. So in this case, M is bigger than 0. Line is going up. Here, the line is going down. So looking left to right, we're going down. And so the slope is negative. Positive goes up, negative goes down. If the slope is 0, then the line is perfectly flat. And the only other possibility is that the line is vertical up and down, and in that case the slope, or M, is undefined. Okay, so positive is up, negative is down, 0 is flat, and vertical is undefined. Okay. If I actually want to measure the slope, how big is it or how small is it? I need to measure 2 points. So I've got one point here on the line, another point here, and I'm measuring how far over, which is the run, versus how far up, which is the rise. Think of a stair step. You could do this with stairs in a 2-story house. Measure how far you would step your foot versus how much you rise up. That ratio is what we are calling M, which is the slope. If I am given 2 points, an x1, y1, and an x2, y2, I still use run and rise, but I can measure it by subtracting x2 minus x1 over y2 minus y1. So here's my formula. But remember, the formula has the minuses. You're going to fill in whatever your x's and y's are. I've got parentheses here because they could be negative. So looking at our example here, I picked some that had negatives. So let's see M. Here's M again. We've got Y. Okay, here's a Y. Here's another Y. X and my other X. They do match up to -4, -5, and 6. Here's the minuses from the formula. So -4 minus a -6 is -4, plus 6, which is a +2. And if I've got 2 minus a -5, that's 2 plus 5, which is 7. So this line is going up because it's positive. Now I also wanted to show you that it makes no difference which one I write first. Here I used 2 minus 4. Here 2 minus 4 is second, but it makes no difference. -6 minus a -4 is -6 plus 4, which is a -2. -5 minus 2, a -7. But a negative over a negative is a positive. So you see, these are exactly the same number. All right, let's see. What if I have this situation? 2 points, 2, 3, 2, 5. So I plotted them here for you. Over 2, up 3, over 2, up 5. And visually, you can see that's a vertical line. 3 minus 5 is a -2. 2 minus 2 is 0. But remember from our basic math, 0 in the bottom part is really bad, making the whole problem undefined. So, undefined slope means vertical line. So, different forms of lines. X equals a number. That's a vertical line. M is undefined. So if you see x equals a number, that's a vertical line. Y equals a number. That's a horizontal flat line with a 0 slope. Where they are crossing is at whatever that number happens to be. If I've got an x and a y, then this is slope-intercept form. M, the number in front of the x, is the slope of your line. So positive is up, negative is down, 0 is perfectly flat. B is where the line is crossing the y-intercept. Another form of the line that we might need on occasion is called point slope. To use it, I have to give it a slope, and I also have to give it any point that lives on the line. Doesn't matter which one, it'll give me the same form of the line. We also have something called the general form of the line, and all that means is we put the x's and y's on the left and whatever number we might have on the right. So let's look at some homework problems. They gave us a graph here. So looking at this graph, I'm looking, the slope is certainly negative. And it's negative because I am going down. How far did I go down? Well, let's see. I'm picking actually this point and that point, and I seem to be going down 3, and I have a run of 3. So down is a minus 3, and so that slope would be a minus 1. Now just comparing, 0 slope is perfectly flat. Verticals are undefined slope. If I had the perfect diagonal line, which is at 45 degrees upward here, that has a slope of 1. And if I've got the diagonal the other way, it's a slope of minus 1. So what that means is if I have a slope that's in here, it's got to be a fraction between 0 and 1. And if it's steeper than the diagonal, it has to have a slope bigger than 1. All right, so in this case, we are going up is positive, but here I'm going down. Let's see, if we are perfectly flat, it's 0. But if we are vertical, it's undefined. All right, looking here at question 3, I see I've got an M, which is my slope. So that says the line does go up, and it's crossing on the y-intercept at minus 4. So remember, what does this slope mean? Well, slope of 2 is 2 over 1. 1 is the run, so I go over 1, up by 2, over 1, up by 2, and it's crossing at negative 4. So this is my line with a positive slope. What about this one? X plus 4y is 4. So looking at that, well, it's in a really bad format because I don't really have y by itself. But I can get y by itself. I can move the x to the right. If I move a variable across an equal, that's really the same as subtracting it. And so on the other side, it's a minus. What about this 4y? Well, to clear the 4, I divide everything by 4. And so looking at this is really a minus 1/4. So I'm going over 4, down 1. Over 4, down 1. Over 4, down 1. Okay, and so I can actually see on the B part here, it's crossing at 1. What about this y equals 4x minus 9? All right, so it's going up. That's my slope. B is minus 9, so the y-intercept is at minus 9. In question 6, let's see, I've got a minus 9/7. So that's a negative slope, so it's going down. I would see that it's got a run of 7 and going down by 9. But it's crossing here at negative 5. All right, what about 7 here? Let's see. I've got y equals 2x plus 6. Slope is 2, so it is going up. The y-intercept is 6, but they're asking me where is the x-intercept. Well, the way you find an x-intercept is you set the y part to 0, and then you solve for whatever x happens to be. So move the 6, got a negative 6, divide both sides by 2, and so I see that the x-intercept is at minus 3. Now notice they wanted the place and not the particular point, so you don't need to write it as minus 3, 0, just the number minus 3. All right, what about this one? We've got 8x minus y is 40. And then we're looking for the x-intercept. Well, any x-intercept means the y-coordinate is 0. All right, so that's easy. I just set the y piece to 0. And now I can solve and I get x is 5. All right, so that's my x-intercept. They also want the slope of this line is 8, because I can put it in that format to know that. And I also see by doing that I actually get that the y-intercept is minus 40. In question 9, they say, okay, write an equation of a line that has this slope and this y-intercept. Okay, easy enough. I know a slope, I know the b, so minus 2x plus 7. In question 10, I've got write the slope intercept with a slope of 4, and it must go through the point 3, 0. All right, so I don't exactly know what's the y-intercept. So I use point slope. I plug in my value for m. All right, I plug in the point I know, which is 3, 0. And when I simplify this, I'm going to distribute the 4 in, and I get y is 4x minus 12, which is the equation of the line. All right, question 11. Same deal. I've got a slope. It is a fraction. I've got a point. So let's see. I'm going to plug all the information in. I'm going to plug in my x1, which is 8. Plug in m, which is 9/2. And I'm going to plug in my value of y, which is -4. So notice the minus is in the formula. Minus a -4 plus 4. All right, so here I've got to distribute 9/2 times x. I've got 9/2 times 8. I'm going to cross cancel. 2 goes into 8 4 times. And 9 times 4 is a -36. But don't forget, I've got this plus 4 over there on the left. So I need to move that to the right. And I see that my form now is y equals 9/2 x minus 40. All right, in question 12, all they're giving me are 2 points. And they want us to figure out, well, what is the equation of the line that goes through those 2 points? So the first thing I need to do is figure out, well, what is the slope of that line? All right, so I fill in the y parts. I fill in the x parts. And I figure out that the slope of the line is 8/7. So stop and ask yourself, is that slope bigger than the diagonal or less than the diagonal? The diagonal had a slope of 1. And this number is bigger than 1, so it is steeper than the diagonal. All right, so I plug in my slope. I plug in my point, and then I start simplifying. 8/7 times 7, the 7's cancel, and I get an 8. I need to move this -3 from the left to the right. So it's -8 plus 3, which is a -5. And so that is in slope-intercept form. And if I would like to put it in standard form, I simply can move the x and y to one side. So I can move the y this way, the -5 to the left. That's one possibility. If I just hate fractions, I can multiply all the way through by 7. All right. Let's see, in this problem, they want me to figure out the horizontal and vertical lines that go through the point -3, 6. All right, well, if it's horizontal, that's perfectly flat. That has a slope of 0, and it looks like y equals a number. And the number is the y value. All right, so here's my point, -3 and 6. So, well, what's my vertical line? Well, vertical lines look like x equals a number, and that's just the x coordinate, which is -3. All right, let's see. Write out an equation of a line that does this. All right, slope is -9. My point is 2 minus 1. Let's see, minus a minus is a +1. I've got a -9 that needs to distribute inward. All right, so a minus 9x, got an 18, got a plus 1. If I move it across the equals, it's a minus, and 18 minus 1 is 17. Let's see, when a line has a slope of 9/4 going through 4 minus 4. So here's my x1, my slope of 9/4, and my y coordinate of minus 1. Minus a minus is a plus. I need to distribute. When I distribute, the 4 will cancel that 4. All right, and finally move the plus 4 to the right. And so I would have minus 9 minus 4, so a minus 13. All right, let's see. Got 2 points. Want to find an equation of a line that goes through there. All right, so simply again, the y's are on the top. The order you pick them makes absolutely no difference. So I'll let you go through that. Let's see, an application. A car rental agency charges $150 per week. That's a base charge. Plus 10 cents per mile to rent a car. So write an equation that represents this, where x is the number of miles. Well, this is a linear relationship. All right, so 0.1 multiplied by x miles plus our base charge of 150. So the question is, how many miles did you drive if it cost me $250? So looking at the equation, it is a line crossing at 150. It's going up as a slope of 0.1. So the question is, when do we reach 250? Well, let's figure that out. So 250 equals that. So move the 150, that's 100. Divide by 0.1 on both sides. And we figure out that we would have driven 1,000 miles. All right, what about this one? Got a farmer. He's buying a new tractor. And the new tractor is $146,000. And after 10 years, he can trade it in with a value of $83,000. So just like a car or any machine, it depreciates over time. So let's see, we start off at time 0 at 146,000. After 10 years, it's down to 83,000. So what do I know here? Well, I know where it's crossing on the y-axis is at 146,000. I do know the run for 10 years. The rise, well, the rise is going down. We're going down from 146,000 down to 83,000. And so by doing this, I see my M is minus 6,300. So there's my model. My model is minus 6,300t plus 146,000. So this model is valid between 0 and this number. The question is, well, where did that number come from? I mean, why is that number even there? Well, let's see. If I continued my line if I continued this, at some point, the value is going to be absolutely 0. So I'm going to call this t years. What it turns out that value is 23.174. At that point, the value is 0. And again, how did I get that? Well, I simply set y to 0. And then I solved for 0 equals minus 6,300 t plus 146,000. And that's where that particular value of t came from. All right, well, that concludes our first section on lines.